Hey, what's up, guys? Welcome to another day of beautiful mathematics. Today we get to do the absolute value inequalities instead of less than ones. Today we're doing ones that start off as greater than symbols. So whenever you solve a greater than one with absolute value, your final statement ends up to be one of those or statements. You'll have a less than on one, a greater than on the other, and these ones, so yesterday with less than, we always put the two dots and shaded in between. With greater than original absolute value inequalities, you put the two dots and it's always going to be shaded outside of those two dots. So it's going to be nice and easy. You'll just have the two options, two things you have to remember. Less than is inside, greater than is outside. And then less than can be written as that compound inequality with the two numbers smushed together. Greater than is always this or statement for your last final statement. Okay, so remember, isolate the absolute value and then go about solving your two inequalities. The first one matches. The second one, we flip the inequality and change the sign to a negative. All right. So solve these easily by adding 3. So it looks like y is greater than 10. Or, don't forget to write that, add 3. Y is less than negative 4. If you wanted to, you could flip that around and put the negative 4 first. But, it's fine. Put it on a number line. Negative 4 would be on the left. 10 would be on the right. These are both open circles. And we're always going to be shading outside for these number lines. This next one is already isolated. So you'd have your first one, y plus 4 is greater than or equal to 6. And the other one, flip the inequality and change the sign to a negative. Again, very easy to solve. Looks like we have y is greater than or equal to 2. Or y is less than or equal to negative 10. Negative 10 would be on the left, 2 would be on the right. This time we have closed circles and shade outside. Simple stuff. All right, number 3. Notice the absolute value is not isolated, so before we can write our two inequalities, we must add 7 first. So it looks like we'd have the absolute value of x over 3 minus 1 is greater than or equal to negative 5 plus 7, 2. Okay. So now we've got the absolute value isolated. We go ahead and write our two inequalities. X over 3 minus 1 is greater than or equal to 2. X over 3 minus 1 is less than or equal to negative 2. Okay. So since there's a fraction in this problem, our first step is going to be to get rid of it by multiplying by the common denominator of 3. So remember, these 3's would cancel each other out. 3 divided by 3 is 1. 1 times x is x. And then 3 times 1 is 3. And 3 times 2 is 6. After that, just one more step, add 3 to both sides. So x is greater than or equal to 9. Or, let's see what we get on this one. Again, fraction, multiply by 3 to get rid of it. Nice and easy. X, not over anything anymore. X minus 3 is greater than or equal to negative 2. Again, add 3. And negative 2 plus 3 gives me 1. There's my solutions. On a number line, 1 would be on the left, 9 would be on the right. Closed circles, shade outside, always. All right, number 4, we've got less than or equal to 0. See what happens on this one. Absolute value is already isolated, so we can write our two inequalities. 2 times x plus 1 over 3 is less than or equal to 0. 2 times x plus 1 over 3 is greater than or equal to negative 0. Negative 0 is still 0, so it's the same, but notice the symbols are different, so it is important to have both of them. So again, we've got a fraction. We'll multiply by 3 to get rid of that fraction. The 3's would cancel each other out, leaving me with the 2 times x plus 1. And then 3 times 0, still 0. Distribute the 2. 2x plus 2 is less than or equal to 0. Subtract 2. 2x is less than negative 2. Divide by 2, and x is less than or equal to negative 1. Over here, again, it's going to follow the same exact thing. We'll actually get the same exact answer because 0, it's the same, just the symbol is going to be flipped around. 3 divided by 3 is 1, so we'd have 2 times x plus 1 is greater than or equal to 0. 2x plus 2, and we distribute. Subtract 2, so 2x is greater than negative 2. Divide by 2, and x is greater than or equal to negative 1. So what does this look like on a number line? Well, we got negative 1 for both of them. So we just put the negative 1 in the middle. It would be a closed circle shaded outside. So what does that really mean? That is all real numbers. Now, if that were an open circle, it would not be all real numbers because not everything is shaded. It would be everything except, if that was an open circle, it would be everything except negative 1. So that's kind of interesting. But this one turned out to be all real numbers. Number 5, absolute value needs to be isolated. So you subtract 5 from both sides. The absolute value of 2x plus 9 is greater than negative 2. And I stop right there. Anytime I have a negative over there on that side by itself, once the absolute value is isolated, I stop and think. Okay, so we're taking the absolute value of something, which again is the distance from 0, which again has to be a positive number, and it needs to be greater than a negative number. So when I take the absolute value of something, it's always going to be positive. And is any positive number going to be greater than a negative number? Yeah, that's always the case. So anytime you have that absolute value isolated and it's a negative number over there, it's going to be all real numbers. And remember, that number line would just be a completely shaded number line. Okay, number 6, don't stop and think yet, because the absolute value is not isolated. If we add 5 to both sides, we no longer have a negative number. Now that the absolute value is isolated, go ahead and write your 2 inequalities. First one matches. Second one, flip the symbol and change it to a negative. All right. There are fractions in this problem, so we're going to get rid of that by multiplying by the denominator of 2. So the 2 divided by 2 would cancel the x's out. 2 times 3 is 6, and again, 2 times 3 is 6. Add 6 to both sides, and x is greater than 12. Or, let's see what this one gives us. Again, a fraction, so multiply by the denominator, the common denominator of 2. The 2's would cancel there, leaving me with x. 2 times 3 is 6, and 2 times negative 3 is negative 6. Add 6. They both cancel, so I get x is less than 0. Okay, and so that's a pretty standard one. Just put 0 on the left, 12 on the right. Open circles, shaded outside. Again, nice easy day. Let me know if you need any help with that. This is going to conclude section 4. So tomorrow we'll be starting our review. All right, good luck, guys, on my math lab assignment. Let me know if you need any help. See you later.